This video is for Chemistry in the Earth System, Unit 2.1, Parts of the Atom. Today's essential question: how can the average atomic mass for an element be determined given the masses of its isotopes and the relative abundance? Our first main idea: average atomic mass. Often, it is useful to consider the general properties of an element, even if several isotopes are present. For example, an environmental scientist might want to study the behavior of oxygen in the atmosphere. There are three naturally occurring isotopes of oxygen: oxygen 16, oxygen 17, and oxygen 18. The scientist's work will be concerned with the oxygen that actually exists in the atmosphere rather than with each isotope separately. So scientists have found that they can use the average atomic mass of a specific element to be accurate in quantitative measurements. The average atomic mass takes into account the masses of all of the naturally occurring isotopes of a particular element, weighted according to their abundance. Because it is a calculated value, it is likely to include decimals. These are the values typically listed on the periodic table of elements. The average atomic mass of oxygen is 15.999. The whole number atomic mass of radioactive elements shown on the periodic table is the mass of the most stable isotope of that element. Remember, this only applies to the more radioactive elements at the bottom of the periodic table. So the average atomic mass of hydrogen is 1.0079. This is very similar to the atomic mass of hydrogen 1, because over 99.9% of hydrogen occurs in this stable form of hydrogen 1. Weighted averages take into account the abundance of the naturally occurring isotopes of an element. Abundance is usually expressed as a percentage of the element of each isotope. To find the atomic mass of an element, follow the following steps. First, find the percentage abundance and the atomic mass of each naturally occurring isotope of that element. Next, multiply the percent abundance by the atomic mass of each isotope. Find the sum of those products, meaning add those numbers together. Then divide that sum by 100. Let's take a look at a sample problem.
Deciding which college to attend is an important choice in your life. You want one that has it all. Here at Atomic Mass University, we provide the smallest particles in the universe with an expansive education at an affordable price. AMU, founded a nanosecond after the Big Bang, is located just outside the nucleus on a pastoral 10 to the 23rd acre campus.
Okay, so you know some elements have several isotopes. Using AMUs, we can calculate the average mass of the isotopes of an element. Why would we do that? Well, because there's a good chance you'll have to do it on a test. Besides, the mass in AMUs listed for each element in the periodic table is actually the average mass of the isotopes of the element. It's the mass of the hypothetical average atom for each element. We'll show you how to figure out the average mass in AMUs as it's listed in the periodic table.
Don't worry though, it's easy. You need to know the atomic mass of each isotope. You can look that up in your textbook. And you need to know a thing called the natural abundance of the isotopes. Natural abundance describes how much there is of a particular isotope in comparison to other isotopes of the same atom. For example,
of all the hydrogen in the world, 99.985% of it is the hydrogen isotope with no neutrons. It's pretty much just a proton. So, 99.985% is the natural abundance of the hydrogen isotope with no neutrons.
you can look up the natural abundance of an isotope in your chemistry textbook. Then, a quick calculation gets you the average mass of the isotopes. We'll show you how.
We'll use two of hydrogen's isotopes to show you how to calculate average mass. Find average mass by multiplying the natural abundance of each isotope by its atomic mass. Then, add the contributions of each together. Again, you can find the natural abundance and atomic mass listed in a general chemistry book. So, here we go. The hydrogen isotope with no neutrons has a natural abundance of 99.985%, and the isotope with one neutron, called deuterium, has a natural abundance of 0.015%. The mass of the first isotope is 1.00783 AMUs, and for deuterium, 2.01410 AMUs. Multiply the mass of each isotope by its natural abundance. Notice that when we're dealing with natural abundance, we have to slide our decimal 2 places to the left since they're really percentages. Now, we add the two products together. The result is 1.0080 AMUs, the average atomic mass of the hydrogen isotopes.
One more sample problem for the road. Determine the average atomic mass of the 3 naturally occurring isotopes of magnesium given the following data. So how are we going to do this? Since magnesium has 3 isotopes, okay, again, reference the values shown in the table. We're going to take the percent abundance of each isotope, multiply it by its given mass, this mass of that specific isotope, not from the periodic table, because that's the average atomic mass, which is what we are calculating here. For each of the 3 isotopes, multiply the percent abundance by the isotope's mass, and then add those values together. Once you have added those values together, divide everything by 100, right, because we're dealing with percentages here. And in this particular example, we'll come up with 24.305 AMU, which is the value that you will find on the periodic table. At this point, you should be able to generate a full and complete answer to today's essential question. How can the average atomic mass for an element be determined given the masses of its isotopes and their relative abundance?